All right, as we are starting things off here for Friday on day 4 of our ignition system lecture notes, just a friendly reminder that if you are planning on submitting the coolant system reassessment, the last opportunity for you to do so is tonight at 11:59 p.m. Okay? If you do not submit this reassessment, what you are telling me is that your score on that assessment that we had last week Friday, you are okay with. Okay? Keep in mind, Monday we went through the information on the worst answered question. So if you answer that question wrong on the test initially and you follow along with us on Monday, you could literally submit just that and you could get a point back. Which again, if you got a 57% on the test, is going to be enough to get you into the passing 60 percentile.
So, wait.
We don't understand what we're saying.
I'm kind of dumb, okay?
No, just, you're not done.
You're very intelligent.
Okay. Just gotta focus a little bit more. Sometimes that's harder to do when you have an earbud in your ear.
No, basically it's harder actually. But I'm also kind of dumb.
Alright, anyways. Today we're gonna wrap up our notes here. So again, I just want to go back into yesterday's notes. Obviously you wrote this stuff down, so you don't need to rehash it or put it down in your notes. But again, on a spark plug, there are 4 main parts of a spark plug. Okay, we've got our center electrode. Okay. Also known as the center terminal. The center electrode is this part right here that goes right through the center. You normally can't see it unless you look at the bottom. Okay, this top part where the spark plug wire or the ignition coil plug connects to, that's part of that center electrode. You have your ground electrode down here. The gap between your center electrode and your ground electrode is where we create the little spark that ignites your air-fuel mixture. Okay, so that's our ground electrode. The ceramic insulator. Not super easy to be seen here, but technically speaking, let me circle it there. It says NGK, right? That's the ceramic insulation. Since we're pushing 30,000 volts of electricity through this, we need to have a very, very good insulation. And ceramic is probably the top tier on that. The only problem is, again, it's brittle, which means we have to take very, very extreme cautions not to damage this.
So the thing doesn't go in the block.
Correct. So the electricity doesn't short circuit and find a shortcut. Okay. So that's the ceramic insulator. And then finally we have our steel shell. The steel shell is literally this metal part looking on the spark plug. It's got the threads, so that way we can thread it into the cylinder head. It's got our sealing agent, if you will. In this case, it's a washer or a gasket. It could have been a tapered edge, which is usually at an angle. And it contains our 5/8 inch nut on here that we can put a socket on to be able to loosen or to torque that up to the proper specifications. All right. We also need to understand that our spark plug has various different reaches. Again, reaching into the cylinder head. So basically from here to here can be a different length depending on what type of cylinder head you're running on what engine. So you got to make sure that that specification is being monitored and found, so you purchase the correct spark plug for your application. And that could be different between not only manufacturers but also vehicles. The shell comes in 2 flavors. It's either going to be 18 millimeter wide diameter, okay, how wide this is, or it could be 14 millimeters wide. Okay, that's usually the 2 standards. Okay, and again, the sealing capability of the cylinder head to the spark plug, so that way our air-fuel mixture doesn't leak out of our combustion chamber, is either going to be through a washer or a tapered seat. You're going to need to be able to identify this once you remove a spark plug from the shop cars. Okay, the lab sheet's going to ask you, what kind of seal does this have? Those are your 2 options. The washer is really easy to see because it's got this loose part. Assume that if it doesn't have this loose part and it has kind of an angled cut, that's tapered. All right. Again, nothing overly complicated in that scenario. Again, we have a very high resistance in our spark plugs. Okay, we're looking at 5K to 10K ohms of resistance. Again, most normal wires, we want to have 0 ohms of resistance because we don't want to impede the current flow of the electricity through the wire. In this case, we need to have a higher resistance simply because we want to reduce RFI. And if you look in your notes on Tuesday, we talked about what RFI was, radio frequency interference. Right. We don't want to interfere with the computer systems and wireless signals that are being sent throughout the vehicle. Okay? And that's one way to dampen that. But because we're pushing 30,000 volts through our secondary system, we can very easily overcome that 5 to 10,000 ohms of resistance. So it's not that big of a deal. Spark plug gap. Again, we kind of got into talking about, here, let me draw this. We've got our ground electrode right here. Okay, basically a little hook. And on a side note, I do want to emphasize that that ground electrode can come in various different shapes and sizes and applications. In this case, you have a single ground electrode. You may have a ground electrode on some spark plugs that have like 2 or 3 or 4 different ground electrodes. Sometimes they're like a continuous piece. It depends again on the application and what the manufacturer expects out of the spark plug in order to ignite that air-fuel mixture to produce as much power from that air-fuel mixture burning, as much efficiency, so we're completely burning that air-fuel mixture, okay, which obviously extends our gas mileage and eliminates lower emissions, our drivability, okay. Then we also have our center electrode, which is going to be right there. The gap between those two is a measured amount specified by the manufacturer. Most modern day spark plugs that are made out of platinum and iridium are set from the factory. There's very little gapping that you have to do. Okay? You still may want to measure that with a tool. Older spark plugs like this that are made from copper, they're never set properly. I pull them brand new out of the box, I gotta check, and then I gotta use a tool to bend this ground electrode so the gap between the center and the ground is the proper measurement. So that way I create the correct size spark to be able to ignite that air-fuel mixture. Okay. Again, we never want to actually clean spark plugs. We replace them. We did that already. Spark plug heat range. Talking about how, because the spark plug is literally inside the combustion chamber and it's going to get very hot in there, thousands of degrees, we need to dissipate that heat so the spark plug doesn't melt. Okay, and because it's threaded into the cylinder head, we are going to then be able to dissipate the heat up through the shell and out basically through the insulator. Okay, and depending on how long of an insulator that is, right? So if this one is like right here, that's a shorter one. That's a little bit of a longer of a distance. The shorter the distance, the colder the spark plug will run. The longer the distance, the hotter that spark plug will run. Okay? And again, there's various different reasons for why you would want to have a hot plug versus a cold plug. Okay? And again, it depends on what you're trying to ask out of the engine and how the engine is designed. Okay? Just keep in mind, hot running spark plug, longer insulators. The heat has to travel a longer distance, so it stays in there longer. All right? Cold running spark plug, shorter distance for that heat to travel to, which means it can dissipate faster, so it remains cooler. Now, I want to emphasize this. Cooler spark plugs does not mean like 20 degrees Fahrenheit. It's still going to be hot to the touch, right? To you, it still be hot. It will just be cooler than a hot running spark plug, as weird as that sounds. Okay?
It won't be as warm.
Yes. Well, it's still going to be hot, but it's not going to be as hot. Okay, this is where we left off yesterday. All right, good thing I wanted to review that again to go over spark plug parts, things to look out for, and to note when you are going to go purchase a spark plug. So if you're going to go do this yourself on your own vehicle, you got to take into account all of those factors. Okay? Again, you can't just go and buy something off the shelf and hope it works. It's not going to. All right. Obviously, we've been talking about single spark plugs here, but we have to understand that cylinders are going to you're going to have more than one cylinder, you're going to have more than one piston. We're going to have more than one combustion chamber burning air-fuel mixture at any given point in time. Okay? And the computer is not only monitoring TDC at cylinder 1, but then it's inferring that information about cylinder 2, 3, 4, depending on how many cylinders you have. And it is literally commanding the ignition coil to turn on for each one of those in a particular sequence. Okay? That sequence of which cylinder fires in which order is called the firing order. Okay? That's not even up here. Okay.
It's on the next one.
Yeah, I'm jumping ahead. It's called the firing order. So in this case, I got a good picture, right? Here's a 4-cylinder engine. Here's the front of the engine right here. That's the snout of the crankshaft. This is considered to be cylinder 1, cylinder 2, cylinder 3, cylinder 4. Okay? So you would literally count that in order. However, the firing order is not 1, 2, 3, 4. Okay? It doesn't go down the road. Okay? And we'll talk about that why in a second.
So, how do you change the firing order then? From
So the only way to change the firing order is to change the crankshaft. Like literally.
that would make sense.
Okay.
Yeah.
So the crankshaft dictates
Right.
which piston is moving where, because of the journals, right, and the offsets and all that sort of stuff. So if you're going to change the firing order of an engine, you got to change the crankshaft out, but then you also have to reprogram the computer because the computer needs to know what the new firing order is. So it's
And possibly change the camshaft with it.
then you have to do that because the valves are opening up in a different sequence as well. So you're looking at completely changing the engine.
Function of the engine.
Yes, it's not just like, I'm just going to turbo swap things out. Even turbo swapping is not what you think it is.
No, it's
Okay, we're adding a turbo. We got some questions yesterday. Hey, how often do I change my spark plugs out? The typical time period of what you're looking at is somewhere between 30,000 and 100,000 miles. Okay? Now, keep in mind, check the manufacturer's recommendation of when you change your spark plugs out. Because it depends on what type of spark plug that they want you to use will dictate how many miles that it's supposed to last.
So my brother's car is like 170,000 miles on it,
Mhm.
but the engine got rebuilt at like 40,000.
Okay.
And we still haven't changed the spark plugs. How long can it keep going?
That's a good question. I guess you'll find out, right?
Just see how long it lasts.
Just see how long it lasts. Now, interestingly enough, the longer that lasts, right, the spark plugs are probably still going to try to do their job. The problem is now my ignition coil has to work much, much harder in order to get that spark to jump across that gap because it's probably deteriorating a lot more than you probably realize, which means you're putting a lot more strain on this part. So at some point in time, I'm starting to get a misfire. Why is that? I haven't changed my spark plugs in, 200,000 miles. You may have also need to replace your ignition coils now, which makes things much more expensive. So just something to consider. Morning.
Why do you call it?
All right, anyways, 30,000, 100,000 miles. newer platinum and iridium spark plugs are going to be able to last 100,000 miles. They are much, much more durable in that environment. Copper spark plugs, right? This type right here, back in the day, was all you could get. You're looking at maybe 30,000, and then you got to change these things out. Okay, so there is a time frame on that, and these are a maintenance item. Okay, engine firing order. This is what I was originally getting at. Okay,
Wow.
So firing order is a vocabulary word. What's the definition of firing order? Well, it's the sequence in which the spark plugs fire to ignite the air-fuel mixture.
Huh?
Crazy, huh? Keeping in mind that the spark plugs fire, or it's supposed to fire, as the piston is approaching TDC during the compression stroke. So, a typical firing order for a 4-cylinder engine is going to be 1342 or 1432.
Uh-huh.
You want to write that down.
Oh.
Okay? The typical firing order for a 4-cylinder engine is cylinders 1, then 3, then 4, then 2. Or it could be cylinder 1, and followed by cylinder 4, then cylinder 3, then cylinder 2.
What's more common?
Either of them. I've probably seen more 1342s, but that doesn't necessarily mean it's more common. Now, that's just for a 4-cylinder engine.
Wait.
Okay, I'm not going to give you the
What about a W16?
I'm not going to give you a firing order for a V6 or a V8 or a V12, V10, W16, because that can get kind of obnoxious. But again, you have to understand the vehicle manufacturer that's producing the engine is going to have a different firing order, which gives the engine different characteristics. As weird as that sounds, okay? Hey, I've got a Chevy Corvette.
Sweet.
Okay? V8 engine. As you start it up, it's going to have a very distinct sound. Okay? People will say that's a very American sounding V8.
Yep.
Right?
It is.
What that means is that they can audibly tell a difference. It's got a grumble to it. Right? Exactly. Compare that then to a European sports car V8, like a Ferrari. The Ferrari has what's considered a flat plane
I don't know
crankshaft.
how to do that one.
The angle at which the journals are separated from itself means that the engine has a different firing order for those 8 cylinders in comparison to an American V8, which means the Ferrari has a different audible sound to it. Okay, it sounds like it's going to rip something in half
Tell me what this
instead of
is.
the
Tell me what this is.
low audible grumbling to it. Okay,
What about that one?
okay, that's a supercharger. That's something totally different.
Oh my god, is that
Okay. So, next time you hear a Corvette drive by, pay attention to how that engine sounds. Okay, Emerson, that's enough.
Alright, my bad.
And then hop on and see what a Ferrari V8 sounds like. All right, the new Corvettes, the C8s, they totally changed over their structure of their engine. They put a flat plane crank in that V8. That Corvette now sounds like a Ferrari. Okay, that's an American V8.
Hey, why this?
Because you could have, just because it's American does not necessarily mean that the Europeans can't put in that style of crankshaft to make that kind of sound.
Makes sense.
Like this. Like
Imagine this for a second. If you've ever heard a Harley Davidson motorcycle, okay, you know what a Harley Davidson sounds like. You can be blindfolded. Harley goes by.
hate Harleys
You can
so
say
much.
that's a Harley.
They're overly loud for no reason.
Okay. Compare that then to like a Honda V-Wing. Honda goes by, it has a different sound. There's a reason for that. Firing order plays a part into that.
What does camming an engine do?
It opens and closes.
I don't want to get into that too much, but basically it's a larger lobe. It pushes the valves open more for a longer period of time, so you get more air into it.
Okay, so it's just more
That means more power?
Yes, which means more power. Yes,
Yeah.
that's camming the engine. So you get at lower speeds, it's a much more like
rigid.
it's gonna sound like it's gonna die, but then when you go up to higher RPMs, it still allows for more air, so you get more power.
It usually gives
How would like a flat six work?
A flat six,
Yeah.
like a flat plane six. I don't know what that would sound like. I would assume it's probably a characteristic of a flat plane V8. Is that what you're? Or no? Are you talking about like a Subaru
Yeah.
or a Porsche? Yeah, Porsche has a very distinct sound as well, right?
Yeah.
And that's that's because it's a boxer engine. The pistons are actually opposed to one another, going 180 degrees instead of at a 120 degree V.
That's cool.
That's personally my favorite kind of engine.
What is?
A Porsche flat six.
What about a flat?
That's not going to be on the test and irrelevant.
What about a flat four?
Okay, so right here you see
Don't even hit.
an animated picture of a inline six-cylinder.
Put that in.
Okay. You can see here how the spark plugs are sparking, and there's a sequence in which it travels. Okay? And that's because each piston is going to be in a different part of the four strokes as it is traveling up and down based off of that. So that way we can get continuous power into my engine, which means I have continuous power to my wheels. Okay? And it's all about turning that crankshaft accordingly. Okay? Here's a better picture of a four-cylinder firing. Okay? So again, this is the front of my engine because that's my vibration damper.
Wow.
Okay? So we've got cylinders 1, 2, 3, and 4. The firing sequence here is 1, 3, 4, 2. 1, 3, 4, 2. 1, 3, 4, 2.
We get it.
You get it?
Yeah.
Okay? That's the firing order. And that camshaft is opening and closing those intake and exhaust valves according to that firing order. Okay? But again, we need to spark the spark plugs at the top of the compression cycle in that order.
Ah, I see it.
Okay.
You see it?
There we go. Oh, we gotta get our Plicker cards. All right, Tech A. Tech A says that spark plugs have high resistances to prevent radiostatic interference. Tech B says spark plugs are not needed on a direct ignition system.
I bet it's Chase.
Jason's on the they're going to something.
Chase isn't coming today.
Oh yeah, they go. I don't think he goes to
How about us asking dudes?
All right, let me pull this up on my phone.
Too easy.
On your whale.
It's only easy because you've been educated.
I can guess. I could probably guess this, right?
See, Levi's just smart. He can walk in, he knows the answer.
That's because he probably looked at everybody else's phone.
Probably.
All right, now everyone's looking back to see what he put down as an answer.
Got me.
Put down B.
I got you. I think I got everybody. Yep, I think I got everybody. Emerson, I got you. Okay. And since Levi, I'm going to pick on you because you got the right answer. What's the correct answer? A is the correct answer.
What was the?
Okay. Tech A is correct. Spark plugs have high resistances, and the reason why they have that is to prevent radiostatic interference. 5 to 10,000 K, or 5 to 10,000 ohms of resistance.
Yeah.
Spark plug wires are going to have a similar one. Okay. Direct ignition systems still need spark plugs. Just how we fire those spark plugs, Easton, a little differently than different other styles, right? Instead of this type, which is a what again? That's a distributor.
Yes.
Distributor-less coil pack. Each one of these is a coil pack. There you go. So it's just different ways of firing the spark plug. All right, now we're gonna get into some really nerdy stuff. I'm talking like auto nerd stuff. Okay. The information I'm about to share with you is not always 100% necessary to know in order to change the spark plugs out. Okay? But if you are looking at potentially diagnosing a misfire or diagnosing an issue in your ignition system, this is what you got to do. Easton,
Do you have a heat gun?
I have a heat gun.
Can I borrow it
No,
for like a few minutes?
not right now.
What? To dry these damn boots off? They've been wet for 3 days.
That's not my fault.
Uh,
If you need to go to the bathroom, just still let me pass, okay?
that.
But we don't have like.
All right, an oscilloscope. An oscilloscope is the graphing calculator of a digital multimeter. You know, a digital multimeter, you put the red lead in and black lead, it just gives you the number.
Yeah.
Just like a calculator, you punch in 2 + 2 and it equals 4.
Yeah.
But then you go to math class and you're like, okay class, we're going to deal with formulations with like slope, and you got your graphing calculator.
Yeah.
You punch out the equation, you hit the button, and on the graphing calculator it actually shows you the graph, right? Oscilloscope is a graphing calculator.
Ah.
The digital multimeter is just a normal calculator. The nice thing about an oscilloscope is it shows voltage over time. If I just used a digital multimeter and I was checking this stuff out,
Just shows you.
I would literally just get numbers as this was happening. The problem is the scale, we're looking at milliseconds. Okay, milliseconds. This whole event right here takes about 5 milliseconds.
Which is really fast.
Really fast.
Quicker than you can think about it.
Think faster probably than you can blink. I don't know how fast a human person can blink.
I can like.
Okay, I want to say 15 milliseconds is your blink.
Oh. Ah, you saw that?
Anyways, when you actually use a digital multimeter in this particular test, digital multimeter is not even going to register it because it happens too fast. An oscilloscope, known in the industry just as a scope, by the way, okay? Auto technicians don't like to say oscilloscope because it's too fancy. We just like say, hey, get the scope. Then what we're going to do is we're going to get this tool out. Yeah,
100 milliseconds.
100 milliseconds.
Yeah.
This happens in 5.
I can like way faster.
That was the average.
It's not a competition to see how fast you can blink. Okay?
Not fast.
Now, the fun part about this oscilloscope is, A, they're really expensive.
How much are they?
Okay?
Like,
I mean, you're
probably a couple hundred.
my Snap-on scan tool out there. That's like $1,200. Okay, you could get a Pico scope with everything to hook up. You can run it off your laptop. That's still probably in the ballpark at about $1,000. Okay, you're only typically going to purchase this tool is if you are a professional that's going to probably be using this to obviously make money. Okay, but one thing we got to keep in mind is when I hook this up to my ignition coil, okay, or my ignition system, and I'm measuring the voltages that are going through that, it's going to make this graph right here, okay? You absolutely must write this down in your notes. You need to draw the graph, and you need to label it in the correct spots here,
How do I do that?
okay? It is very important that you do this, okay?
You're gonna be wasting my time, man.
I'm not wasting your time.
No.
Okay? You need to know that if you ever see this type of graph on a scope, you are looking at a spark plug event. Okay? Now, as weird as this is, technicians are trained to know what each one of these parts are, and they can look at a graph from an oscilloscope, and they are able to diagnose if the spark plug is functioning correct, if the ignition coil is not working properly, without taking anything apart. This takes some experience. This takes some
Was that good? Wait.
training on how to read this graph, just like how you go to algebra class and they need to train you on different calculations and how to use the graphing calculator. But then on the test they say, hey, here's the question, or here's an equation. Draw this graph out. You were trained. Okay, mx plus b, or whatever, y equals mx plus b. Okay, I know what the slope is. I know what the y-intercept is, right? Because you've been trained to do that.
It's good.
That's not too bad. That's not
Just-
too bad. Okay.
Nah, you should.
Keep in mind, yeah, you don't need necessarily all of the squiggles.
Oh, man.
All right, let me show you. I'm gonna go in here. I'm gonna draw this out. What it could potentially look like on your notes. Okay.
Yeah, we don't need that.
Whoops. Line drops down here. Okay. Might come up a little bit. Boom. Okay. Comes down. Oscillation. All the way across.
You didn't do it in a different
Again, identify the parts of this. From here, when this drops down to where this spikes up, that is known as dwell time. We talked about dwell time this week. What's dwell time?
I don't remember.
Let's review. Dwell time is the time that the computer turns on the circuit to allow battery voltage to flow into our ignition coil to build up that magnetic field. As soon as the computer shuts off that circuit, that magnetic field collapses, and that induces 30,000 volts in the secondary circuit, and it fires my spark plug. Right there, the spark plug is receiving voltage, and we're jumping across the center electrode and ground electrode to create our spark. Okay? How long does that spark last? From when this comes down to right here. This is the amount of time that that electricity is jumping across the gap at the spark plug, right here. That's why we call it the spark duration. Okay, I don't know how fast it is, but it's like probably a little less than a millisecond. Okay? Now, the coil oscillations is this kind of like reverberation that's happening after we get done with the spark plug. The coil oscillation is actually all the excess energy that we didn't use getting kind of used up and dissipated. It then returns back to our battery voltage until we need to spark that spark plug again. It drops down, we're charging up that magnetic field. Boom, we fire the spark plug. The spark plug is burning, we dissipate the energy, boom. Okay, that's what that graph means. Okay, that's what we're looking at here in this case. Yes?
What should I write down for dwell time? Like, what is it?
Dwell time is going to, well, we have a definition at the beginning. Probably on Tuesday. Tuesday or Wednesday you should have in your notes. But basically, again, dwell time is the ignition coil receiving battery voltage, the circuit turned on, we're building that magnetic field. Okay? And again, we're not turning it on for a very long period of time. This is milliseconds. Boom, 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 boom. Okay? It's fast.
That's for each spark.
This is happening in each spark plug as we are firing it. That's what's occurring.
Do you test
Right here.
every single spark plug, or do you just do one?
If my engine has a misfire, I'm literally what I'm going to do is I'm going to take my scope out. I'm going to scan each one of these. And I'm going to be looking at this graph. If I have a misfire, I'm going to have a very different looking graph than what would be elsewise.
As we continue with group photos
Okay.
in the PAC today for your book,
Oops.
the groups we have taking their
So
pictures
you're
for the
saying
second
firing
hour,
line would be
the
like
youth and
during
government,
the
gamers club, and the
The-
freshmen, sophomore, and junior. And
What would happen is the spark duration line would look it would look way different. I'm not going to get into that.
At the very start of second hour, get your picture taken, and then get your half. Youth and government, gamers, freshman, sophomore, junior, and senior class officers.
All right, I think most of the stuff I'm going to actually cover out in the shop. All right, time out, folks. We got 2 minutes. Yeah. 2 minutes is not going to kill you. Easton. All right, sit down for a second. Easton, stop. Chris, Roberto, sit. John, sit. Okay, tools that you're going to be using out in the shop next week. As we show it, we have spark plug sockets. These are specially designed sockets to remove and to torque spark plugs. They've got a little rubber boot inside them. Oops.
Why isn't it called a glove?
Okay, we've got a kilovolt tester. We've got a couple different ones of these. This is basically going to test the voltage that's occurring through spark plug wires. Okay, so we can actually measure how many volts our ignition coil is producing. Here's a spark plug gap gauge. We can measure the gap between the center electrode and the ground electrode, right? Know what that distance is, and it also has parts on here that will allow you to make adjustments to that gap to get it to be at the correct gap. Okay, so we'll use that tool as well. Okay? All right. Monday, when we come back from weekend, we're going to review, I should say review, but we're going to go in and you guys will have opportunities to ask questions and to summarize what we talked about this week. Okay?
Can we not be in the shop so